doing is spiral number 3, lesson 8, and this is called systems of equations, and what we're using is a term called elimination, and this will allow us to find a point of intersection between two lines. So this equation, 4x minus 8y, is the equation of a line, and 3x minus 6y is also another equation of a line. We call this a system because there's two of them. And before, when we were looking for something like this, or created something like this, we would always use Desmos to find the solution. This means find the point of intersection, a shared point between those two graphs. Now, before, when we discussed substitution, right, we want our equation to be always rearranged properly. So we would have said, taken this equation, solve for it, and we get, well, imagine we have something like this. Y is equal to 3x plus 2, and y is equal to 5x plus 8. So this is just an example of what we used to do before. We used to label both of these equations 1 and 2. We then did this. We let equation 1 equal 2 by saying 3x plus 2 is equal to 5x plus 8, and we would solve for x by moving stuff to the left and to the right and just getting x by itself and the constants to the right, solving, and we get x equals 3. Once we've done that, the most important thing that we did, once we found one of the variables, either the x or the y, we had to go and substitute back into our original equation. So we have x equals 3, so we'd sub x equals 3 into equation 1. And when we do that, we literally take equation 1 and replace x with a bracket of, well, we guessed it, the number 3. And when we do the rest of this, we solve and we have y is equal to 11, and this means that our solution is xy. Remember, it's a point, an intersection, a point shared between those two lines of equations 1 and 2, and we get 3, 11. Now, we're going to go and study this thing called elimination. Now, when we're eliminating something, what we're actually trying to do is we're trying to get rid of either the x or the y of an equation. Okay? Now, if I take a look at this first equation, I'm going to label it 1 and label the other one 2. Now, the easiest way to get rid of the x's would be to subtract them, right? Because, you know, x minus x is 0, right? So it essentially disappears. So let's do that. So we're going to imagine that this is kind of like a subtraction equation. So we get 2x, we get this. X minus x is 0, but then we have 2y is equal to 4. And that's because y minus negative y is really y plus y. So that's 2y. And then 10 minus 6 is 4. And then we just solve. So we get 2y over 2 equals 4 over 2. And we solve and we get y is equal to 2. So now, let's go and take a look at what we did before. Remember, when we got our first variable, we would always substitute back into our original equation. One of them at least. So let's do that. So we have y equals 2. So what we're going to do is we're going to sub y equals 2 into 1. And we've got x plus bracket equals 10, and we substitute our 2 in, and we end up with this. Drop the brackets, we get x plus 2 is 10, and then we're going to subtract 2 from both sides to move the 2 over to the other side, and we end up with x is equal to 8, and that means our solution is this. Copy that down, and we'll move on to the next problem. So now this next problem is 3x plus 4y equals 15, and 4x minus 4y equals negative 8. So let's label both of the equations 1 and 2 just like before. Now, imagine if we decided we were going to go and get rid of the y's, right? If I took 4y plus negative 4y, those would cancel out. We would end up with a 0, right? So all we'd be left with was x's. So let's do that. Because they are opposites, when we add them, they cancel each other out. So let's do that right now. So we're going to have 3x plus 4y is equal to 7, and then 4 plus negative 4, so that's going to give us a 0y. And then 15 plus negative 8 gives us, I guess, 7. So we end up with 7x is equal to 7. So now, once we get 7x is equal to 7, we're going to actually get rid of the 7 on the x. So what we have to do is we have to divide both sides by the number 7, and we find that x is equal to 1. So now what we're going to do is we're going to substitute back into the original equation 1. So we substitute x equals 1 into 1. So now we get this. 3 bracket plus 4y equals 15, and we're going to put in a 1 here. So 3 times 1 is 3 plus y. 3 plus 4y equals 15. So 3 times 1 is 3 plus 4y equals 15. So now what we're going to do is we're going to get rid of the minus of the 3 from both sides by subtracting negative 3 from both sides. And we end up with 4y equals 12, which gives us this final solution here. And our solution is that. So essentially we end up with xy equals 1, 3. Now, pause a second, copy this all down, and then we'll move on to the back page of this. Alright, let's move on to the back page. The first thing I want you to do is I want you to read these concepts. First, based on what we did before, we chose either our x or y to remove, and then we basically isolated it and added and subtracted. But this time what we're going to do is we're going to multiply with the number from the other equation for both sides. So let's take a look at this equation here. So this system here is 3x plus 2y equals 28 and 5x minus 3y equals 15. So let's label both of these equations 1 and 2. By doing so, I have decided that I want to get rid of the y's. So in this case, there's a 3 on this equation 2 for its y, and a 2 on this equation here up top for its y. So what we're going to do, the top equation, we're going to multiply by 3. So remember, whatever is here, we're going to multiply it by this. Okay, we're going to multiply the 2y by this. Now we're going to do the same for the bottom. So this has a 2y, so we're going to multiply this whole equation by 2. So now what that does is it produces two different equations. So imagine if I take 3 and multiplied 3x by 3, 2y by 3, and 28 by 3. You're going to get 9x plus 6y equals 84. So we multiplied each of those numbers by 3 and it gave us a new equation. And we do the same for the second. So 5x times 2 is 10x. And then minus 3y times 2 is minus 6y. And then 15 times 2 is 30. And that's what we have for our second equation. So now remember we said we were going to get rid of the y's. Because the 6y and the minus 6y are opposites, all we have to do is add these two equations, and we end up with this. The minus 6 and the plus 6 disappear, but now we have 19x is equal to 84 plus 30 is 114. So the next thing that we have to do is we're just going to divide both sides by 19. And we end up with x is equal to 6. So the next thing that we have to do is we're going to take a look at what we did before. In the previous thing, what we did was we substituted back into our original equation here, which is 3x plus 2y equals 28. So we're going to do that. Sub x equals 6 into equation number 1. So that means we have the following. 3 bracket 2x plus y equals 28. And we're going to punch in the number 6 here. So once we've punched in the number 6, 3 times 6 gives us 18 plus 2y equals 28. So remember, the 3 times 6 gives us the 18, and then there's a plus 2y, and then we bring down the 28. So now, in order to get rid of the 18, we're going to subtract 18 from both sides. And we end up with 2y equals 10. And that eventually solves to y is equal to 5. So now, the solution for this problem, xy, is going to be 6 and 5. And we're done. So now let's go and take a look at this next problem. So I'm just going to move this down a little bit, and then we're going to work through this. So this problem here, this second problem, 2x plus whatever, uh, 2x plus 2y equals 190, and 25x plus 20y is equal to 275. Now, the only reason I'm showing you this problem is that sometimes you don't have to multiply both of the equations by a number to get rid of it. If I look at this, that 20y on the second equation would make that 20y on the second equation is easy to go and mimic in the first equation. So what we're going to do is we're going to multiply the first equation by 10. So now below, because there's not enough space, you're just going to draw an arrow. So the new equation for the first line is going to be, well, 10 times 2x is going to be 20x. 2y times 10 is going to be 20y, plus 190 times 10 is 1900. So that's what we get for the top equation, and then we just copy down the bottom equation. So now we look at those two things. We have plus 20y and plus 20y. So in order to get rid of it, we're going to have to subtract both of those equations. So when we do subtract it, 20x minus 25x is going to be minus 5x. And then 1900 minus 2175 is negative 275. Now, in order to get the x by itself, we must divide both sides by negative 5. And that gives us a final answer of x is equal to 55. So now, looking back at our previous problem, we always have to substitute back into our original equation. And I love substituting back into the first equation. So let's do that. We're going to sub x equals 55 into 1. So we're going to have 3 bracket plus 2y equals 190. Now, the x is 55. So 2 times 55 is going to be 110 plus 2y is equal to 190. So now we're going to go and move the 110 to the right side and get 2y by itself. So we get 2y equals 80. Now we're going to get y by itself by dividing both sides by 2, which tells us that y is going to equal 40. So therefore our solution is xy is equal to negative 55 plus 40. Now, the last thing I want you to realize is that your homework for today is going to be this. We're going to be doing page 216, 1 ACE, 2 ACE, and 4 ACE. That's it for your homework. Get it done.